Hi all, in today's class we are going to see about bridge rectifiers. So here in depth we'll see empathy part of the bridge rectifier, that is we have to provide a maximum efficiency, that is utilizing the full wave, and also eliminates the costly and heavier components, and low ripple factor and better performance, and better transformer utilization, and increase reliability and safety. So let us see about full wave bridge rectification and construction of the full wave bridge rectification. The full wave bridge rectifier is a rectifier that will use 4 diodes or more than the bridge formulation. So in this diagram you can clearly see about the 4 diodes, how it is connected, and where the diodes are named as A, B, C, D. It forms as like a bridge, and the resistor load is connected in between the bridge. So let us see the principle of the full wave rectifier. So when an AC signal is applied across the diodes, during the positive half cycle, the terminal 1 becomes positive and terminal 2 becomes negative. So positive half cycle has been generated. And next, this will cause A and also C to become a forward bias, and the current will flow through its direction, where B and D will be in reverse bias, and it blocks the current flowing through the direction. So the current flow will be in the terminal 1 and D4 and 3 and 2. So this is the working of during negative half cycle, the terminal 1 becomes negative and also terminal 2 will become your positive. So this will cause the diode B and D to be in forward biases and allows the current to flow through them. So at the same time, the diode A and C will be in reverse biases and also block the current. This is the waveform for AC input and diode A and C and diode B and C and the total output current. Next is filter circuit. The output from full wave rectifier is pulsating DC with noticeable ripples, which is unsuitable for practical application without further modification. Next is converting a DC voltage to pure DC voltage. We can use a filter, which means a capacitor that acts as a filter. So during positive half cycle, the diode A and C conducts, and the capacitor acts as a ripples, and the rectifier pulsating voltage start decreasing less than the capacitor voltage. So around half of the charge present in the capacitor gets discharged, and during negative half cycle, the diodes B and D starts conducting, and the process same happens again, and this causes the current continue to flow in the same direction. So this is the AC output, and next one is the DC output. Discharging, charging, discharging, charging. Okay, happens. Third one with filtration. It's a basic prototype of your full wave rectifier. So it's a transformer. This is a capacitor, and the LED acts as a load, and this acts as a switch. Next, let us see the ripple factor of the full wave rectifier. So the ripple is unwanted AC components remaining when converting the AC voltage into DC waveform. Even though we are trying our best to remove all the AC components, there is still some of the small amount of output being pulsates the DC waveform. So here the ripple factor is that RMS value of the AC voltage and DC voltage -1, and the efficiency is something that output DC divided by input power. So the efficiency of center tapped full wave rectifier is 81.2. Next, see the form factor of the full wave rectifier. So form factor is equal to RMS value divided by average value. So the form factor of the full wave rectifier is around 1.11. Next, let us see the advantages and disadvantages of full wave rectifier. So the advantages of full wave rectifier is that full wave rectifier has higher rectifying efficiency compared with the half wave rectifier. So here around 81 percentage. This means it converts AC to DC effectively, and there is a low power loss during no voltage signal is wasted in rectification process. Next is the output voltage of the center tap full wave rectifier has lower ripples than half wave rectifiers. And next one is disadvantages of full wave rectifier. Center tap rectifier is more expensive than half wave rectifier and tend to occupy lots of space. Let us see the summary of today's session. So we saw about full wave rectifier and its construction and its working principle and performance characteristics, and filtering circuits and its advantages and disadvantages. In performance characteristics, we saw the four main factors, that is ripple factor, efficiency, form factor, and transformer utilization factor. And the ripple factor of full wave rectifier is around 0.48, and ratio is RMS AC by DC voltage. And for efficiency, it's 81.2, and ratio is DC output by AC input power, and the form factor is around 1.1, and ratio is RMS value by average value. And I hope you understood this session well. This is a quiz. Try to solve it. Thank you.